We're in Rosen, Discrete Mathematics and its Applications, section 8.1 on applications of recurrence relations. And several topics are covered in this chapter, and I recommend reading the chapter very thoroughly and also looking at the homework problems naturally. Because there's a lot of variety in how we can apply recurrence relations in a lot of different contexts in which they might arise. It's difficult to account for them all in a short presentation or two. We will talk in this video about the Fibonacci numbers. All right, just remember what a recurrence relation is. If we have a sequence of integers such that an equation for an can be given in terms of one or more of the previous terms in the sequence, anywhere from a0 up to an minus 1, where the starting point for that recurrence relation would be n sub 0, and it's some non-negative integer, an index. If we have such a sequence that has that type of relationship, we call that sequence a solution of the recurrence relation. And then those terms in the sequence that can't be defined by the recurrence relation would need to be established as initial conditions to fix the sequence's value. Okay, so here is the origin of the Fibonacci numbers. Leonardo Fibonacci was thinking about this very problem many centuries ago. He's thinking about pairs of breeding rabbits placed on an island, one of each gender. They don't breed until they're 2 months old, and then after they're 2 months old, each pair produces another pair each month. And we're going to assume that they are a male and female so that they themselves can breed when they're of breeding age. So we want to find a recurrence relation for the number of pairs of rabbits on the island after n months, and we'll make the assumption that they never die. All right, here's how it proceeds. Here's the first pair of rabbits that are put on the island, and this is at the end of month 1. We have one pair of rabbits on the island. And at the end of month 2, that'll keep disappearing, I apologize, we still only have one pair of rabbits on the island. However, at the end of month 2, they become breeding rabbits, and so they move over into this reproducing pairs column, and that's what the yellow line represents. And then they produce, by breeding, another pair of rabbits, and that's what the red dash line represents. So now at the end of month 3, there are 2 pairs of rabbits on the island. The pair that was there before and the pair that was born to those that had been there 2 months before. So you can see that 1 is equal, or that 2 is equal to 1 plus 1. All right, well, at the end of month 4, this breeding pair will produce another pair. That one that they just had born to them will not age well enough, so that at the end of month 4, another pair of rabbits is produced, signified by that red dashed line. So how many rabbits are on the island? Well, the 2 that were there before, plus the 1 more produced by that breeding pair of rabbits that was there 2 months before. So 1 plus 2 is 3. All right, how about at the end of month 5? Well, at the end of month 5, this pair of rabbits will now be old enough to produce new rabbits, and this pair of rabbits will continue to produce rabbits. So we'll have 2 rabbits that are production aged, or breeding aged. This pair of rabbits still stays there, and then that pair of rabbits aged, and then they both produce two new pairs. So how many pairs are on the island at the end of month 5? Well, there's the 3 that were there before, plus the pair of rabbits that were born to the 2 pairs that had been there 2 months prior, because now they're of breeding age, equals 5. And then we can go to the next. We've got one more that ages to breeding age, and then each of these will produce 3 pairs, and then these 2 that were born the month prior will stay in that same non-breeding pair category. So we have 5 pairs that were there the month prior, remember they never die, plus 3 more pairs that were born to those rabbits that were there 2 months prior to give us 8. And there's the familiar Fibonacci sequence. So if Fn is the number of pairs of rabbits after n months, there's F1 equal 1 pairs of rabbits on the island at the end of first month. F2 is 1 pair of rabbits on the island at the end of the second month, and there's our initial conditions. And then the number of pairs after n months is the number of pairs that were there the previous month because they never die, and the number of newborn pairs, which is the same as the number of pairs of rabbits that were there 2 months prior. That's Fn minus 2. And that gives us the Fibonacci recurrence relation with the initial conditions F1 is 1 and F2 is 1. It turns out also to work with F1 is 1 and F0 is 0. But it's fine to do F1 is 1 and F2 is 1. And the number of pairs is the nth Fibonacci number.